Hey listeners, welcome back to the channel. Today we are diving into Class 12 Mathematics Chapter 1 Relations and Functions. This chapter is the foundation for calculus, algebra, and even competitive exams like JEE and NEET. Let's break it down with clear examples so that you will never forget. In this video, we will cover the topics like relations, functions, composition and inverse function, and binary operations. Don't forget to like, share, and subscribe for more Class 12 math tutorials. Chapter Overview of Relations and Functions. NCERT 2026-27 edition has 28 pages to cover this chapter. In this chapter, it covers introduction to domain, codomain, range, and the idea of relations. Types of relations: empty, universal, reflexive, symmetric, transitive, and equivalence relations. Types of function: one to one, on to, bijective, real value based function, and the graphs. Composition of function: how functions combine. Invertible functions defines definition and example. Binary operations operation defines on set. And you have miscellaneous exercises with mixed problems to practice. Exam relevance for this chapter. CBSE board weightage is around 5 to 7 marks and JEE main weightage is around 3 to 4%, that is 1 to 2 questions per shift. Key skills tested here are identifying relation types, function properties, composition and inverse calculation, and binary operations on set. Section 1. Relation. What is a relation? A relation is a connection or rule that links the elements of one set to the elements of another set. Mathematically, a relation R from a set A to set B is subset of the Cartesian product A cross B. Basic terms. Domain. The set of all first elements in the ordered pair. Range. The set of all second elements in the ordered pair. Codomain. The entire set B. Different type of relations on a set. Empty relation. A relation containing no elements. Universal relation. Every element of set A is related to every element of A. Reflexive relation. Every element is related to itself. If you are wondering what is the difference between universal and reflexive, a reflexive relation requires that every element in a set relates to itself. However, it can also contain other relationships. A universal relation goes much further, dictating that every element relates to every other element and itself. It encompasses all possible combinations of a Cartesian product. Symmetric relation. If A is related to B, then B is related to A. That is, if A comma B is R, then B comma A is also R. Transitive relation. If A is related to B and B is related to C, then A is related to C. That is, if A comma B is R and B comma C is R, then A comma C is also R. Equivalence relation. A relation that is reflexive, symmetric, and transitive all at the same time is called equivalence relation. In mathematics, an equivalent relation is a binary relation that allows you to group similar elements within a set together. For example, equivalence, that is equal to. This is the most standard example. Any number equals to itself. Reflexivity. If A equal to B, then B equal to A. Symmetry. If A equal to B and B equal to C, then A equal to C. That is transitivity. This image represents all possible combinations of relation and functions. The left topmost image indicates one element in set A has multiple relationship with elements in set B. On the second image, R1 represent, that is the arrow mark represent the relation where one element in set A has multiple element in set B and one element in set B has multiple relationship in set A. In the middle, a function is represented as f. The set A elements has unique relationship with set B elements. This is represented as 1 to 1. Like that, you have wide range of functions. We'll go through it a little later. Section 2. Let's move on to functions. What is a function? A mathematical function is a rule that assigns each input value, the domain, to exactly one output value, the range, often written as f of x equal to y. It acts like a machine where you plug in a x value, process it, and get a single distinct result. Key concepts: domain and range. The domain is the set of all possible input number, while the range is the set of all possible outputs. Function notion: f of x. It simply means the function and indicates x is a variable being inputted and y is the output value. For example, in the function f of x equal to 2x plus 3, if your input is 4, then you will read it as f of 4 equal to 2 of 4 plus 3, which is 11. The vertical line test. To determine if a graph represents a function, no vertical line can pass through more than one point at a time. If a single x gives multiple y values, then it is not a function. This means exactly when f of x is giving y as output, f of x will always give y as output. If not, it is not a function. Let's look at the mathematical definition of a function. A function is a special relation where each element of the domain maps to exactly one element of the codomain. Here, exactly one is the keyword. For example, f of x equal to x square. X square maps every real number to its square number. Another example is a equal to 1, 2, 3 and b equal to abc, then function f equal to 1 comma a, 2 comma b and 3 comma c. Types of functions: 1 to 1, which is called injective function. In this, each input has a unique output. For example, f of x equal to 2x. On to surjective function. Every element of the codomain gets mapped. Nothing is left out. For example, f of x equal to x cubed. From R to R, where R represents real number. Bijective function. It has the properties of one-on-one and on-two functions. For example, f of x equal to x plus 1, where the x values are integers. Understanding these properties is crucial for calculus and higher algebra. So let's go through it one by one. Number one, one-on-one or one-to-one. Injective. You can refer the image for more clarity. Definition. A function is one-to-one if every unique input maps to a completely unique output. No two different inputs can share the same output. Example from the image, f of x equal to 2x. Why it works? If you input two different numbers like x equal to 3 and x equal to 4, you get two completely different outputs. 6 and 8. No two numbers will ever produce the same result. Number 2. Onto, which is subjective. A function is onto if every single element in the target output set is actually hit by at least one input. There are no leftover or unused numbers in the output set. For example, f of x equal to x cube from R to R. That is all real numbers to all real numbers. How it works? Every possible real number has a cube root. For any output y, you can always find an input x to create it. Number 3. Bijective. A function is bijective if it is both one-to-one and onto at the same time. This means every input pairs up perfectly with exactly one unique output and no outputs are left over. It is perfect and clean pairing. For example, f of x equal to x plus 1 for integer z to z. Why it works? It is one-to-one because every integer gives a unique result, and it is onto because every integer can be reached. Section 3. Composition and inverse function. A composition of function is an operation where you apply one function to the result of another function. It is written as f of g of x, which is represented as given below. To solve the composition, you work from inside out. That is, step 1, evaluate and write down the inner function g of x. Substitute the entire expression into the outer function f of x anywhere you can see an x. Step by step example. Let's say f of x equal to x squared and g of x equal to x plus 3. To find out f of g of x, substitute g of x with x plus 3, that is f of x plus 3. Replace x in f of x with x plus 3. That will give you x squared plus 6x plus 9. Similarly, if you want to find g of f of x, substitute f of x into g, that is g of x squared, then replace x in g of x, which will give you x squared plus 3. One point to note is order matters. You should always do inside out, not outside in, if you want to get the correct answer. Next, the inverse functions. An inverse function is essentially undoes or reverses the action of the original function. For example, if a function takes input x and gives you y, its inverse takes y as input and lead back to x as output. It is denoted as f of minus 1 of x. Critical requirement for inverse function: bijectivity. A function must be bijective, that is, both one-to-one and onto, to have a true inverse function. If two different input gives the same output, that is failing the horizontal line test, the inverse would map one input to two output. This violates the core definition of function. How to find an inverse function? The algebraic method. To find f inverse of x for an equation like f of x equal to 2x plus 5, first replace f of x with y. That will give you y equal to 2x plus 5. Then swap x and y. That will give you x equal to 2y plus 5. Now solve y. That is, move 5 to the left hand side, which is x minus 5 equal to 2y and y equal to x minus 5 by 2. Replace y with f of f inverse, that is f inverse of x equal to x minus 5 by 2. The connection between both composition and inverse function. Composition is the definitive tool used to prove whether two functions are truly inverse to each other. Two functions f of x and g of x are inverse if and only if both composition simplify perfectly to x. That is, f of g of x equal to x and g of f of x equal to x. When you visualize this loop, the relationship forms a perfect circular mathematical loop. Please refer the image below. 4. Binary operation. A binary operation on a set is a calculation that combines two elements of set to produce another element of the same set. Formally, a binary operation star on a set S is a function that maps an ordered pair from S cross S directly to an element in S itself. Number 1. Closure property. The golden rule. For an operation to be truly binary, it must be closed. This means that if you take any two elements, say A and B, in set S, and the result of A star B must also live inside the set S. Example of closure. Addition is a binary operation on the set of integers, say Z, because adding two integers always return into another integer. 2 plus 3 equal to 5. This is an example of closure. Example of failure, subtraction. Subtraction is a binary operation on set of natural number, say n equal to 1, 2, 3. Because 2 minus 5 is minus 3 and minus 3 is not a natural number, it is not closed. So it's an example for failure. Key properties of binary operation. When analyzing a binary operation, mathematician checks for four fundamental structural behaviors. Number one is commutative. The order of elements doesn't matter. That is, A star B equal to B star A. Associative. Grouping of element doesn't matter when performing multiple operation in a row. For example, A star B star C equal to A star B star C. Grouping is doesn't matter, which is associative. Order doesn't matter is commutative. Identity element. An element E exists in a set such that operating it with any element leaves the element unchanged. For example, A star E equal to A and E star A equal to A. Addition of zero is an example. A plus 0 equal to A or 0 plus A equal to 0. Multiplying by 1 is another example where A star 1 equal to A or 1 star A equal to A. The next is inverse element. If an identity element E exists, then an element B is inverse of A if operating them together yields the identity element. That is, A star B equal to E and B star A equal to E. Let's look at a problem step by step. Problem. A binary operation star on the set of real number is defined as A star B equal to AB plus 2. Is this operation commutative or is it associative? Number one, let's check commutativity. To check if it is commutative, compare A star B with B star A. Calculate A star B. A star B equal to AB plus 2. Calculate B star A. B star A equal to BA plus 2. Hence, it is commutative. Alright, let's check associativity. To check if it is associative, compare A star B star C with A star B star C. Let's look at the left side, that is A star B star C. Evaluate the n side first, that is A star B equal to AB plus 2. Treat AB plus 2 as your new first element and C as the second element. AB plus 2 star C equal to AB plus 2 into C plus 2, that is ABC plus 2C plus 2. Right side, which is A star B star C. Again, let's evaluate the inside first, which is B star C, which will give you BC plus 2. Treat A as your first element and BC plus 2 as the second element. So it's A star BC plus 2, which will yield you ABC plus 2A plus 2. So obviously, left side doesn't match the right side. Hence, it is not associative. Okay, we covered all the topics. Now let's look at few practice questions. Let's assume A equal to 5, 6, 7, 8, 9 and R equal to 6, 6, 7, 7, 8, 8, 9, 9. Right? The first question is it identical? No. Why? If it is identical, then each element of A should have an identical pair in R. That is, R should be 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. In the given question, the result set R is missing 5, 5. Hence, it's not identical. Is it universal? No. Why? In universal, A cross A will yield you, that is, it has 5 elements, so it should be 5 cross 5 will yield you 25 pairs in the result set R. Whereas in the given question we have only 5 elements. Hence, it is not universal. Is it reversal? Yes. Why? If you reverse the result pair, say 6 comma 6, if you put the left 6 or the right 6 to the left or left to the right, similarly 7 pair, 8 pair and 9 pair, the result is going to be the same. So or is equal to or reversed. Hence it is reversible. Is it reflexive? No. Why? In reflexive set, it must contain all the identical pair, then it may also contain more pair, depends on the need. This, because it's not identical, it can't be reflexive. We already established it is not identical. The next example or practice question. Let function of x comma y equal to x cube plus y cube minus 3xy plus 1 be a symmetric function defined for all real numbers x and y. So in the question, f of x comma y equal to x cube plus y cube minus 3xy plus 1, and x and y are real numbers. Now verify that f of x comma y is symmetric. In order to verify symmetry, you need to swap x and y in the expression and see whether it remains identical. So the first step is given is x comma y, x cube plus y cube minus 3xy plus 1. Now substitute x with y and y with x. Then function will become y comma x equal to y cube plus x cube minus 3xy plus 1. If you rearrange it, then f of y comma x equal to x cube plus y cube minus 3xy plus 1, which is equal to f of x comma y. So this function is symmetric. Alright, the next question. Let's say star be a binary option defined on a set of real numbers R, excluding a specific value given by a star b equal to a plus b minus 3, where a comma b are real numbers. These are the three things we need to do. First, find the identity element e with respect to the operation binary. Find the inverse of that element. Then third, if an element satisfies x, then solve x value. Okay. 1. Finding the identity element. An element e is a real number, is an identical element if a star e equal to a and e star a equal to a. This we already saw. Let's apply this principle and try to derive the answer. Apply this definition on the given problem, that is a star e equal to a plus e minus 3, and we saw a star e equal to a, so a plus e minus 3 equal to a. When you move a to the right hand side, e minus 3 equal to 0. Then you move minus 3 to the right hand side, then e will become 0. So identity element value is 3. Now look at the next problem. Find the inverse element. Element b is inverse of a if A star B equal to E, which is the identity element, or B star A equal to E. Okay, let's do the math. A star B is A inverse, so now we'll put A star A inverse equal to E, and then substitute E value as 3. That will become A star A inverse equal to 3. Now substitute this in the original equation, that is A plus A star minus 3 equal to 3. Now move minus 3 to the right hand side. You will get A plus A inverse equal to 6. Now move A to the right hand side. A inverse equal to 6 minus A. That is your answer. Number 3, simplify this complex equation. Now we solve the given equation. X star 4 star X inverse star 5 equal to 7. Let's simplify the first bracket. X star 4, that is x plus 4 minus 3 equal to x plus 1. Now let's solve the second bracket, which is x inverse star 5. X inverse equal to 6 minus 5. So 6 minus x. So 6 minus x star 5 equal to 6 minus 5 6 minus x plus 5 minus 3 equal to 8 minus x. Now substitute these values back into the main equation, that is x plus 1 star 8 minus x equal to 7. Apply the operation one last time, that is x plus 1 plus 8 minus x minus 3 equal to 7. X minus x plus 1 plus 8 minus 3 equal to 7. That will give you 6 equal to 7. Number 4, analyze the contradiction. Variable x cancels out completely, leading to the false statement of 6 equal to 7. This mathematically implies that no real number x can satisfy the equation as written under the standard condition. Let's modify the target value to validate setup to find a unique solution. If the question states h star 4 star x inverse star 5 equal to x plus 4, left hand side simplifies to 6 and right hand side is x plus 4, then 6 equal to x plus 4, then x equal to 2. That is your final answer. Alright, we looked at the concepts and we looked at few example. Now let's look at a study plan. If you plan it properly, say morning few hours, in the evening few hours, this all things can be done within 3 days. On day 1, focus on introduction and types of relation. In the morning, revise definitions and understand the concepts. In the evening, practice examples on the subject. Similarly, on day 2, try to focus on functions plus composition in the morning and solve the NCERT exercises in the evening. Similarly, on day 3, study inverse function plus binary operation, and in the evening attempt miscellaneous exercises and pass CBSE questions. This will help you cover chapter 1 within 3 days and you will be well versed with it when you are done on the day 3. Here are the few tips I would like to give for the success. First, memorize the definition. Don't take a chance. In exams, it's better you write a definition as clearly as defined as possible, right? The things to remember is what is empty, universal, reflexive, symmetry, and transitive. Then, whenever you get time, practice NCERT solved example because this often mirrors exam questions. 3. Focus on functional properties like one-to-one, on-to, and bijective as they are frequently tested. Then try attempting previous year CBSE papers for the pattern recognition. The more you practice the examples, the better it is when you sit in exam. So keep practicing. Alright, that's about it. Thank you very much for joining this video. In short, Class 12 Math Chapter 1, Relations and Functions, is the backbone for higher level mathematics, especially calculus and algebra. Mastering definition, properties, and examples will secure marks in both CBSE and competitive exams. So that's the chapter 1 in nutshell with examples that make the concept stick. If you found this useful, hit the like button, subscribe, and share it with your classmates. Don't forget to practice NCERT exercises. They are the exam goals. If you have any further queries, if you want me to solve few more examples, if you have a specific question that you are not able to solve, please feel free to comment on the section. I'll put a follow-up video on this. Thank you very much, and it's me, Pradap Gopal, signing off.